Alright, here we have a GL2400, as I stated before. This is a monophonic input. It has several different types of inputs. Monophonic, which is 30 of these single input channels, as well as a couple of stereo input channels. I'll talk about those in detail a little bit later, but let's first talk about the monophonic input channel itself. At the very top you have what is known as a little red switch that says 48 volts on it. That's for phantom power. Only use this, or depress that button, if you have a piece of equipment that is attached that requires 48 volts, otherwise known as phantom power. If it's a dynamic microphone, which is quite common for you to use for that channel, do not apply phantom power. Because the reason being is that, say like a dynamic microphone, somebody's using a dynamic microphone and they happen to be leaning up against a rail or something that grounds them out, or they're touching somebody else who is touching a rail or anything like that, and you have phantom power applied, they could get a shock. You want to avoid that. So unless the piece of equipment that you have attached requires phantom power, do not apply phantom power. Examples, once again, for phantom power would be like a DI box or a condenser microphone, such as like a podium microphone or a hanging microphone, or quite often condenser microphones. One of the things you might want to do is leave the phantom power off unless you know for sure, but leave it off, and then you can set up a channel, and if you're not getting signal, go ahead and add phantom power. But don't do that unless you mute the channel first, because otherwise you'll get a big pop in the system. Alright, so let's look down right below phantom power. Let's find out where I'm at. Alright, here we go. Next is Polarity. Polarity button. That's very useful in situations where you might actually start feeling some phasing problems between several microphones that are in close proximity to each other. What happens quite often is you'll have a sound source, such as somebody singing, or let's say a string player, or an instrument that is being picked up with two microphones, and one of them is a little bit different in terms of the distance from the sound source. And what can happen is what's called comb filtering. That's a result of two different waves coming in. Two different waves are coming in, and normally they would be in phase with each other if they're the same distance from the microphone or the source, but one's a little bit further back, so therefore it's lagging behind. You'll hear that quite often in the recording, in which case what you do is you reverse the polarity, so now as one is lagging behind, it may not lag as far behind, or might be actually flipped back over 180 degrees. It's also very useful to go hit that polarity button if you start getting feedback, as that will also reverse the wave form coming into that channel, and which can quite often clear up feedback problems. There are other more common ways to deal with feedback, and I will cover those a little more in depth as we go down or go along in this video series. Next down is a button that says, as soon as I find my finger, line pad. What that button does is it differentiates between you're taking your signal from those quarter-inch input, which is the unbalanced input, or a microphone balanced input. In the case of a microphone cable coming in, which is a balanced input, this also acts as a pad. That means if your signal is too loud, hit this button and it'll decrease it by typically like around 20 dB, decibels, dB SPL. Otherwise, leave it up. I'll explain that more in more detail as we start talking about, as we actually set the gain structure in the board. Next up is the input gain. What you want to do is use this to actually regulate how much signal you're going to allow to come into that channel. Sometimes the signal is too strong, in which case you would attenuate it by decreasing the amount of input. Oh, there it is. Yeah, sometimes folks, I can't figure out which one since I'm running the camera and this at the same time. You would decrease the input until you get the desired signal level. More on that when I actually do a channel setup for you. Okay, the next button down is the HPF, or high pass filter. The difference between an HPF and an LPF is a high pass allows signals above a certain frequency range, allows them to pass on through to the mixer or to the input channel. Whereas the opposite would be an LPF, which is a low pass, only allows certain signals below a set frequency to pass through. In this case, this HPF is set at 100 cycles, which is a pretty deep area, a low frequency. So typically you will actually have this depressed unless the input channel source is something like a bass guitar or somebody with a deep voice like mine. But typically we will go ahead and depress that and shelve out lower frequencies below 100 cycles, mainly because the benefits of the HPF is that it gets rid of a lot of rumble noise. Wind noise is quite often used for that, to get rid of wind noise. There's also, especially if somebody drops a microphone, you don't get as much of a big explosion when that microphone hits the ground. So the HPF, you might want to go ahead and put that in or depress it for most vocals, unless you have somebody who's playing bass guitar or a deep voice like mine on the microphone, or like a keyboard player, since he quite often goes down deep in the low frequencies. You will not depress that particular button, the HPF, on that input channel. Let's go on further. Okay, the next section down on this input is the EQ section. This consists of a high-pass filter, which is actually variable, as opposed to the high-pass filter here, which is depressible. This you can actually vary how much of a signal above a certain range will actually get through the channel. In this case, the high-pass, the high-frequency, which is a shelving type of filter, EQ filter, is at 12 kilohertz. Now the next EQ down is a little different. This is centered around 100. This is centered around 1 kilohertz, but it's variable. These are what's known as a parametric type EQ. So this one is actually centered from 1 kilohertz up to 15 kilohertz. 15 kilohertz down to 1 kilohertz. And what this allows you to do is sweep in. That's one of the reasons why they call it a sweepable EQ as well. Sweep into a frequency, the range that you're having a problem with, and either add some to it, not a good idea, or subtract some in that frequency range. And the more you subtract, the broader the area in which it will actually either subtract or add, broader area that it'll actually add. And once again, you can dial into the area, the problematic area, and fine-tune it. Now, the next one down below that is, of course, the next, which is also a sweepable EQ. And this one varies from 335 hertz, 35 hertz up to 1 kilohertz. Remember, this one started at 1 kilohertz. This one ends up at 1 kilohertz. And once again, you can sweep into an area. Let me just clarify here. You can sweep in from anywhere from 35 hertz up to 1 kilohertz and either add or subtract in that area. I'm going to talk a little bit more about EQ in a later video, but we just want to get familiar with what these dials actually do. And then last but not least is the low frequency shelving EQ, and this one shelves 80 cycles. So anything below 80 cycles, you can actually attenuate it, decrease, or amplify it by about 12 dB. I think this one is set at, or plus or minus 15 dB. You can so low, medium, high, high frequencies. That's how you can actually break up the frequencies that are coming in. Now, of course, a lot of you are probably scratching your head. What are you talking about? More on that later. Don't worry about it right now. Below that is boards. More on that later. There's a button below called EQ in. You depress that by activating EQ. If you have it, there we have it activated. If we take it out, that means the signal does not go through these filters. It bypasses them, comes on straight on down to the auxiliary outs, which is our next section that we're going to talk about. Most of the time you leave this in. This is also, by the way, a good way of checking to if you make your settings for the EQ, you want to compare it to without the EQ, with the EQ, without the EQ. You can do a comparison that way. Most of the time you leave it in, hopefully. Hopefully if you know what you're doing. Alright, next down on this channel, we have our auxiliary sends. There's 6 of them. Auxiliary 1, 2, 3, 4, 5, and 6. What these do, they allow us to send copies, and I stress the word copies, of the signal to other output areas that you might have connected to various other equipment. This way you can create actually unique mixes for each and every one of these auxiliary sends. They're called auxiliary sends, by the way. You'll notice that on the first 2, these are auxiliaries do not have a button. Let me get back to that in a second. These do. Auxiliaries 3, 4, and 5, and 6 have a button that's called pre and post. What that means is you can either have this auxiliary send a signal after the fader, which is down here, so they will follow the signal coming out of this fader, or, and that would be post fader, or they will ignore the fader and you can control the volume via these control knobs here, either pre or post. Even if you have a post fader, you will actually be able to customize the amount of signal going to a particular item that you have connected to the auxiliary outputs. But generally speaking, once you get these set in the way you want them, if you want the signal to be controlled by the fader, you would go post fader. If you don't want them to follow what the fader does, pre-fader. Okay, now of course, auxiliaries 1 and 2 did not have a button. Well, that's because they are hardwired, and you can go in some of these boards and actually change this a little bit, but usually from the factory they are hardwired to be pre-fader, so therefore they will not take a signal after the fader down there, remember? They will not take a piece of that signal and copy it to the respective output. And these, of course, all feed master auxiliary outputs, which are in the section over, and we'll talk about that later. Okay, the next section down, we have our mute button. You hit mute, and this is where you should be very well aware of the mute button, because when you especially if you're changing the phantom power to put it on or take it off, mute that channel first. That way you don't have a big pop go through this channel and then onto the amplifiers and make a big pop in the sound system. So whenever you make those kind of changes, always mute that particular channel that you're working on. Now this mute means there's absolutely no signal going to go anywhere at all out of this channel. Except you can also use the PFL, which is pre-fader listen or pre-fader level. Potato, whichever way you want to call it. AFL is after fader listen or after fader level. And what you can do is use that in conjunction with this 4-segment, I think it's a 4, yes, 4-segment LED VU meter. Or you can also, and that's for just a general idea of what the signal is doing. Or if you have the PFL button depressed, you'll actually get a more concise or precise idea of what the signal is doing up here on this. What was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 segment VU set of VU meters. Now let's go back further. So with a PFL, that's our pre-fader listen. This will actually work even if you have it in the channel in mute mode. So this is one of the ways I quite often will, when I'm setting up a channel for, let's say, a vocalist or a keyboard player or whatever my sound source is, I'll mute the channel first and get my levels set with a PFL here, as well as looking over at the main meter over there. What happens when you depress this also, any of these channels, input channels that you have depressed with the PFL will register over on the main VU meter as a combined group. Keep that in mind, because we're going to be talking about that a little later in the series of videos that we'll be talking about. But at any rate, with your headphones on, you'll be able to actually listen to the signal, even though nobody else can hear it through the sound system, because we have it in mute mode, but you'll be able to listen to it in your headphones, that signal, so you can actually do some settings, some generalistic type settings on that particular input channel before you actually take the fader down, unmute it, and bring the fader up to the desired level that you're going to want for other aspects of the board. Okay, so let's go over this once more real briefly. Once again, 48 volts for equipment that requires phantom power. Polarity, so you can reverse the polarity of the signal. Line pad, that differentiates if you've got something plugged in using one of those 1/4-inch unbalanced cables, such as a guitar or somebody's iPad that's split into 2 signals typically, or whatever. This will actually, you can actually just select that particular input. Otherwise, and that would be with it all the way up. Otherwise, no, with it down. Otherwise, use the XLR input, and this will act as a way of if the signal is too strong for the board, this will knock typically like 20 to 30 dB out of the signal, a significant difference, and I will show that later in other videos about that. But you just want to be aware of this stuff that we're talking about. Input gain, that's how you adjust how much input signal you get. Once you get that established, you should not have to touch that ever again, because once you get a good clean signal, you'll do all your other adjustments via the EQ as well as the auxiliaries and whatnot. High pass filter, once again, that is for shelving out lower frequencies below 100 cycles, and that's actually a gradual decrease in those frequencies. Typically, you'll go ahead and insert that for voices such as females, sopranos, altos, and male voices, tenors. It also gets rid of wind noise, helps also clear up plosions. I think that's how it's spelled. But you will not want to put that, press that button in and shelve out frequencies below 100 cycles if your source happens to be a bass guitar or a keyboard or anything else, such as somebody with a deep voice, that has a lower range that you want to be able to come through this system. Otherwise, they'll kind of sound thin and tinny down a lower frequency range. And of course, we have our EQ sections, which I'm going to talk about more in depth in another video. EQ in and out, which you can either take the EQ out or put it in. Our auxiliary sends, which take a sample of that signal coming in and send it to the various 6 auxiliary masters over here, which we'll talk about later. And of course, remember the auxiliary 3 and 4, 5 and 6, they're in groups. So when you depress this pre and post, it only engages the pre and post signal flow for auxiliaries 3 and 4, and so, by the same token, 5 and 6 are only controlled by that particular pre and post button. And of course, down below, which we didn't talk about before, is pan. This will actually allow us to direct the signal either to the right or to the left in relationship to our assign buttons, which are further down. And I'm going to talk about that right now. Okay, on these channels, on these particular channels, we have assign buttons, which are left to right, 1 and 2, 3 and 4. These correspond to the subs as well as left and right end, which feed the main output fader. What we want to do is we can pan left. Let's just give you an example here. If I pan this channel to the right and just hit left and right, what happens is that signal is only sent to the right output over here, which is actually in disguise can be considered a subgroup, but it's more of a group, and which then sends a signal over to the main output going up to the main speakers in a standard wiring scenario. Let's say I want the signal to show up only on the left side. We would do what? That's right, we would pan it to the left, and therefore only the signal will only go to the left side, since I do not have any of these other buttons depressed. Therefore it will only show up at this fader. Now, by the same token, if I have this pan to the left, and let's just take it out left and right, I go 1 and 2. If I pan it to the left, it'll only show up at channel 1 of the subgroup. If I pan it to the right, it'll show up on channel 2. By the same token, let me find myself again here. If I depress 3 and 4, and I have it panned once again to the left, it'll only show up on channel 3. If I pan the channel to the right, it'll show up over here on channel 4, subgroup 4. Sorry, trying to do these videos on the fly here. I didn't write a script for this. Okay. Most of the time, you are going to probably send the signal. You may actually have this, you're going to set the balance up midway. Balance, pan, it's the same thing, potato, potato. On most boards, it's actually going to be called a pan, because balance actually refers to a different concept with a signal. I'm not going to talk about that right now, but pan in this case. Okay, so most of the time you will actually will not send this directly to left and right. You'll send it to, you will send it to left and right. You will not use the subgroups unless you need to. I'll talk about that application in a few minutes, but typically you will not. You only assign it to either left, right, 1 and 2, or 3 and 4. You may also, if you need to, assign it to all of them. So that means that signal coming in will go everywhere, balanced all over for the main outputs. Okay, and of course, once you have our signal established, we can actually bring the fader up to unity gain. This is where that 0, and you see this thick line right here. That's called unity gain. What we want to do is set our faders, try and set them at least as a target unity gain. What we like about doing that is then it allows us a little headroom. If we want to have a singer or a particular instrument that has a solo coming up, we can actually ride this fader and help bring them up out of the group of other signals being mixed together. We can bring them up out of the crowd, sort of like they stand up higher than the crowd. They're a little bit louder than the rest of the crowd, and then we can bring them back down when they're done with their solo. Okay?